Okay, in this problem, we have a nuclear generating power plant, and it's producing a lot of energy. It's producing around 5 gigawatts. So here's our nuclear power plant, let's say, for example, and it's producing 5 gigawatts of power. Okay, that's equal to the power. Now, 5 gigawatts is actually equal to 5 times 10 to the power of 9 watts. And by the way, a watt is equal to a joule per second. So that's 5 billion joules every second that this plant is producing. Now, the question is, after a whole year, after 1 year, the amount of energy that this plant would have produced, if it came from matter itself, how much matter would that be? So, after 1 year of making energy, what would the equivalent amount of mass be? What's the equivalent mass equal to? So that's the question. Okay? So the way we're going to do this is we're going to say, all right, look, how much energy is that over a year? So let's take 5 times 10 to the power of 9 joules per second and multiply that by the number of seconds in an hour, which is 60 times 60. I don't have a lot of time. I have to go quickly here. So 60 times 60 is 3,600 seconds per hour, multiplied by 24 hours in a day, multiplied by 365 days in a year. Now, if you notice the units here, seconds is going to cancel seconds, hours is going to cancel hours, days is going to cancel days, and we're going to get joules per year. Okay? Now, this turns out to be, by the way, 1.58 times 10 to the power of 17 joules per year. Okay? That's a lot of energy. Now, the question is, how much mass is that? Well, in order to take energy to mass, we need the equivalency equation, E equals mc squared. Now, what we're looking for is matter. So matter is equal to energy divided by c squared. And in this case, we know our energy. That's 1.58 times 10 to the 17 joules. And this is over 1 year, right? Divided by c squared, which is 3 times 10 to the power of 8 meters per second squared. And that is equal to, actually, now get ready for this answer, 1.75 kilograms. So less than 2 kilos of matter provides the energy for an entire year, and for an entire year at 5 billion joules per second. Okay? So this is, understand that, of course, this is assuming 100% conversion, right? So all of this 1.75 kilos would be turned into energy. So that's the end of this problem.